Assalamu alaikum dear students. Our next topic is refraction of light. So first considering the definition of refraction. Okay, so this is just different from reflection that we studied earlier. So it says that the change in direction of light when it moves from one material to another. Let's suppose this diagram here. Okay, so it says that the change in the direction of light. Do you see any change here? Yes, we do have change in the direction of this incoming light. The red line shows the incoming ray of light as it just enters this boundary. It just changes its direction. This is called the refraction of light. Okay, so first we've got to know about some terminologies used during the study of refraction of light. First one is incident ray. You already know what incident ray is, the ray which strikes the other material surface or the boundary of incidence. Okay, so in this case this is the incident ray. Number two is refracted ray. Refracted ray is the ray which after changing in direction, it continues to travel in the second medium. So in this case, this becomes the refracted ray. The point of incidence. So a point of incidence is basically where the first ray or the ray of the incident ray strikes the surface of another medium. Okay. Fourth one is normal. Normal is the perpendicular drawn on the surface of the second medium. Here, let's say this is air and this is glass. So, the normal is the perpendicular drawn on the surface of this glass. Okay, so in this case, this is the normal drawn just as we did in the case of reflection of light. Okay, in this case this would be the normal and it would extend it back into the other medium as well. Fifth one is angle of incident. Very simple. The angle between the incident ray and the normal is called the angle of incidence. The angle of refraction, again, the angle of refraction is the angle which the refracted ray makes with the normal, and it is denoted by theta r, obviously. The seventh one is a little different. You wouldn't have studied it earlier. This is optically denser medium. Okay, optically denser medium is the medium which refracts more than the other medium. Between or among these mediums, the medium which refracts more than the other is called the optically denser medium among these two. Okay, or the medium which slows down the speed of light more than the other medium is called the optically denser medium. Okay, so now which one is optically denser medium? Which refracts more? Here we can see glass is refracting more. It is changing the direction of the light more. So the glass is optically denser medium. It's not concerned with the actual density of the medium. Okay, it's not about the particle density of the medium. It's actually about the refraction angle of that medium. Okay, so I have drawn this ray as incident ray and this ray as refracted ray, but I can also draw this ray as incident ray or this one as refracted ray. I can just reverse this phenomena and I can call this angle I or angle of incidence, and this would become the angle of refraction. I would just have to remove this arrowhead from here and draw this arrowhead here and then draw an arrowhead here. So the light ray would come and strike this point of incidence and go back refracted at a certain angle. In this case, you would see that the angle of incident would be this one, and this would be less than the angle of refraction, which in this case becomes this theta. Okay, so now if light ray enters from a medium to another medium and it is bent towards the medium, then the medium it entered is optically more dense or optically denser medium. What does it mean? It means that if the incoming light ray bends toward the medium, towards the normal, okay, then this medium, which in this case is glass, is optically denser. Okay, now take the reverse case. If we say this is the incoming ray or the ray of incidence or the incident ray, and this is the refracted ray, then what happens? In this case, the angle of incidence is less than the angle of refraction, and the ray would be bent away from the normal. Okay, so this was basic. The light was traveling in this direction, but it moved away from the normal. Why? Because it entered an optically less dense medium. So now you would get it. Okay, so now what is dual refraction? Very simple. Let's consider we have a glass slab. We put it just in an air medium. Okay, so the light which strikes this medium gets refracted towards an angle theta r. Okay, so now what happens when it leaves this slab? It travels along the surface of glass, and when it leaves the slab, it just gets refracted again. But what happens now? As you can see, this is just the reverse case as the above. Okay, so now the light ray travels into the glass, and when it strikes the point of incidence, it gets refracted by an angle which is more than the angle of incidence. Okay, so now the angle of refraction in the first case would be equal to angle of incidence in the second case. An angle of refraction in the second case would be equal to angle of incidence in the first case. Okay, so now what do we see here? We see that if I could just draw it here, that this was the actual direction of the ray, and this is the direction of the ray after finally leaving the slab. Okay, so what do we see? After passing through a glass slab, the direction of this ray won't be changed, but it would just slightly be moved from its original path. Okay, it is just moved a little bit from its original path, but after leaving the glass slab, it would continue it in its original direction. Okay, so now coming to the point number 2, which is refractive index. Okay, so what exactly is refractive index? The ratio between speed of light in vacuum, which we all know that is 3 into 10 raised to power 8 meter per second. Okay, to the speed of light in any given medium is called refractive index. Very simple. Mathematically, it's denoted by n, and mathematically C over V is called refractive index. Okay, C is the speed of light in vacuum, which is equal to 3 into 10 raised to the power 8 divided by the velocity of light in any given medium, in any medium that we want to calculate refractive index for. Okay, so in this case, you already know that speed of light is the highest in vacuum. Okay, so if the speed of light is highest in vacuum, then what would this V be? This V will always be less than or equal to C. Less than in the case of any material medium and equal to C if we just place a C here and we just try to calculate the refractive index of speed of light in vacuum itself. Okay, if we just put N equals to C over C, then we will get 1. But for any material medium, this N would be greater than 1. Why? Because in numerator we will have a greater value and in the denominator we will have a smaller value. Okay, so in every case of material medium, this refractive index would be greater than 1. Just in the case of vacuum, it would be equal to 1. Coming to the last topic, which is Snell's law, it states that the product of index of refraction of the first medium, the product of the index of refraction of the first medium and the sine of the angle of incidence is equal to the product of the index of refraction of the second medium and the sine of the angle of refraction. Mathematically, it's very simple. The product of index of refraction of the first medium to the sine of the angle of incidence is equal to the index of refraction of the second medium to the sine of angle of refraction. What does it mean? Okay, so we will have to know what exactly it says about the refraction of light and how does it govern the refraction of light. Okay, so in this case, if the refractive index increases, okay, in any case, if the refractive index increases, the sine theta I or sine theta 1 will decrease. Okay, if it increases, then it means the speed would decrease. Okay, if this refractive index increases, it means this speed would be less. The speed would decrease. The speed of light would decrease in that medium. So in this case, refractive index increases. The sine theta 1 will decrease, or sine theta I, we can also call this I. Sine theta I would decrease. Why it would decrease? Because this lower the speed of light in that given medium, the smaller will be, or the greater will be the angle of refraction. Okay, so if we just try to increase the refractive index, the sine theta I would decrease, and if we just try to decrease this N2 or the refractive index for the second medium, the sine theta R or the sine theta 2 would decrease. So these two or these four terms would just try to balance each other to just maintain their equality. Okay, let's suppose its value is 3. Let's suppose sine theta 1 equals to 2. Then what would happen? Okay, let's say it becomes 2 into 3. Okay, so if this 3 changes into 2, if the refractive index changes into 2, then the sine theta I would become 3. And if this n2 would just change into 3, this sine theta 2 would become 2 to maintain the equality between each other. So the resultant would eventually be 6 in either of the case. So this is the Snell's law, which governs the refraction of light. Hope you enjoyed it. Thank you so much, everyone.